Not yet, Linda. Excuse me. Felipe.
Maybe.
Could you try a mic check?
Yeah. Can you hear me, Sue? Hello?
Thank you.
This one.
And Waymo, can you do a mic check?
Hi, Susan. Can you hear me?
You're a little soft. When you come in, pump your thing.
Okay. Can you hear me?
Yes, a little bit higher.
Okay, thank you. Thank you.
Okay. Venkat, can you try your mic? See if we're ready to go. Venkat's not here. Okay, well, hope we've got it. Folks, this is IDR. Jeff, would you like to try your mic as well?
Hello, this is Jeff. Sue, would you please copy?
Okay.
Jeff, I can hear you.
You're audible in my gallery.
I'm not seeing, Jeff, I can hear you. Do you want me to run the slides tonight or shall you?
Do so if you'd prefer.
Either way, we'll see if I can do it. If not, it's going to be yours. I think I've figured out the slide forwarding. Okay.
You're loud and clear tonight, so that should work out fine.
Yep, I'm in directly attached place. Okay, folks, this is IDR. This is the second session. Ji Dong has been kind enough to upload the minutes from the first session. Please go ahead and get into the Code MD and check that our recording of your comments is correct. If not, please check it. She's also posted it. This is the Notewell. You should know that anything that you discuss in IDR is under the auspices of the Notewell, which means it has legal IPR things. Please read it. If you haven't seen it, download the slides and read it up close. With that said, we're going to pop right to the rest of the presentation, starting with BGP over QUIC, one that I thought was fun. Hold on just a minute. Robin, you will need to tell me when you want it advanced.
Okay. Hello, Susan. Can you hear me?
Yes, I can hear you quite well. It's a delight.
Okay. Okay. Thanks. Okay. This is Zhenbin. The presentation topic is BGP over QUIC. Okay. Next slide. Okay. I will first introduce the motivation of the BGP over QUIC. First, I think that currently BGP has some challenges. The first one is that BGP session establishment delay is prolonged. This is because when set up a BGP session, a three-way handshake is of the TCP had to be adopted. If the TRS is used for the security, then the TRS handshake authentication is also performed. So the TCP and this the TRS handshake will take more time for the BGP session setup. The second one is the head of line block issue. That is the routing information of the different address families can be sent by BGP over the same BGP connection. So if one packet is blocked, so the sending of the routes of all other address families is also affected. Third one, so that's for the encryption configuration, because the TRS configuration now is per peer, so that is also a little complex. So this is just the challenge of the BDP. And the second one, I think that's the technical trend. With the development of open network operating systems, so now BDP is gradually being integrated into the IT world. So that means in the softwareized device or the cloudified device, BDP is being widely implemented. So I think that the QUIC is also is used for the cloud-based services. So that's in this trend. So using BDP for using QUIC for BDP is becoming a possible option. And also that's because now that's after the development of the cloud network, establishing connection between the cloudified device and the physical network device is becoming popular. So this also propose this higher requirement for the security and network adaptability. Okay, next page. Okay, so now that's let's talk about how what can QUIC bring to BDP. So this is first this brief the introduction about the QUIC. So this QUIC is a UDP based byte stream based reliable data transmission service. This is similar as a TCP. Besides this one, so that's by integrating with the TRS, QUIC can also support functions such as establishing connection with minimum latency and providing confidentiality and integrity protection for the transmitted data. And also there's the advantage of multi-stream multiplexing by using QUIC. So here that is a summarize or some summary of the QUIC functions. So that's the first reliable data transmission. This is similar to TCP. Second one, I think this is support low latency connection establishment. So the third one, so that is authentication of the server or client. Fourth one, so that is provide the higher the security. That is provide the confidentiality and the integrity protection for the transport data. The fifth is support streaming multiplexing mentioned. And the last one, so that is can support the connection migration especially in the mobility environment. So, and also that's if the use the QUIC or the BDP, so that the configuration of the TRS can be independent from the per peer configuration. So it can directly share the basic configuration of the QUIC, so that you can simplify the configuration of the security for BDP. Okay, next slide. Okay, so here that's the brief introduction about QUIC 1-RTT and 0-RTT. So that's this is also the concept of the QUIC. That means when both communication parties initiate a communication connection, if the first data packet may carry valid voice service data, this is called as 0-RTT. If the first data packet does not carry the valid service data, so this is called as 1-RTT. So here, so then we can see that when the connection is set up for the first time for the QUIC, because there's no the TLC parameter. So this in this scenario, 1-RTT has to be used. That means for the first data packet, it will not carry any valid service data. But if the if the QUIC connection is not set up for the first time, because the TRS parameter has been exchanged in the first connection. So that's when set up this the connection using the QUIC. So that's the data packet can be the first data packet for the non-first QUIC connection. It can directly carry the valid service date. So this is the 0-RTT. Okay, next slide. Okay, so that's if we use the QUIC for the BGP, so that there can be the different cases for the BGP using the 0-RTT or the 1-RTT. We recommend for the first BGP first time of the BGP session setup, so that 1-RTT is used. That means the BGP open message has to be sent after the QUIC connection is set up. So the state machine is the same as the existing state machine of the BGP. But if the BGP session is not set up the first time, so that we can use the 0-RTT mode for the BGP. So in this mode, so that the BGP open message can be directly sent without at the first packet of the QUIC connection. That means is need not to wait the setup of the QUIC connection. So in these cases, so that's the state machine for the BGP. So that's the connect state and the active state. That is for used for the TCP. So I think so we think that this state can be simplified. We only to keep the open sent state for the 0-RTT mode of the for the BGP. Okay, next one. Okay, so second is the use case for the streaming multiplexing for the BGP to solve the head of line block issue. So in these cases, so that's because the QUIC for the one QUIC connection, there can be multiple stream, so that the BGP can take use of the stream multiplexing to solve this head of line issues. So there means that the BGP can mapping the message to the different stream of the one QUIC connection of the BGP. There are different options proposed in the draft. So that's the option include that's the mapping stream based on the address family, or mapping stream based on VRF, or the mapping based on the prefix. This depend on the choice of the policy. Okay, next page. Okay, so this is also this is changed accordingly for the event of the state machine, because now as the introduce of the QUIC, so that's accordingly some this is the TCP based event and will also increase this the corresponding the QUIC event that's used for the state machine. Okay, last page. Okay, so next step, we think that the BGP over QUIC has much effect on the existing BGP, and this now that the work is just in the early phase. So that's this draft is just a starting point. We would like to solicit comments and possible co-authors to co-work on the draft and the solution. And then we can have some this the possible open source work, implementation and verification. So that's all. Okay, thanks.
Serge,
Hello?
you're in the queue. Go ahead.
Sergey from Nokia, thank you for the presentation. I think it's useful and interesting work, and certainly not the first time I hear about this idea. So I have a couple of comments. My first comment is about your use cases, and specifically, a lot of your presentation was focused on the delay part. I would argue that RTT delay and this delay with BGP connection establishment is not really an issue. Because if you have, for example, high delay link, which exchanges a lot of routes over the internet or something like that, this time for RTT is negligible. And if you really aim for kind of faster route scenarios in local network, your RTT will be just a few milliseconds. So yes, it's a benefit, but it's just a minor benefit. And I don't think it's worth spending too much time on it. And my second comment is about the encryption scenarios, which you mentioned. So you said essentially what the current BGP over TLS is complex, and you can simplify it with QUIC. It is not clear actually how you're going to do it, because in order to implement this BGP over QUIC solution, you still need to implement certificate management. So you need some kind of PKI solution and a way to distribute certificates between BGP speakers. And I think in general, it's not a trivial task. And on top of it, depending, for example, on the lifetime of your certificates, you will encounter corner cases such as what if your certificate has expired, but you have a long-lived BGP session.
Okay.
Thank you.
Thanks. Okay. Go on. Go ahead. Okay.
No, I'm just
So-
going to say after Jeff, we'll have to cut the line.
Okay, thank you, Sue. So I do want to add to the point from the prior speaker. The certificate issues are going to make this a very interesting problem, along with how the encryption is going to interact with a lot of different types of accelerators and host path implementations. So while I agree that there's a lot of interesting challenges here, I think that there's potentially a lot of interesting good work that can come out of this. One of the things I do want to add into the mix, though, is, well, the TLS is going to give us some level of integrity and privacy as an extra feature. It's still not going to protect your transport session against certain types of attacks. So one of the things we don't see over implementations right now for TLS applications, since they're not typically long-lived enough, is some use of something like TCP/AO. So we're probably going to be looking at that for BGP applications at some time.
Okay.
And,
Okay, so then, do I have some of the clarification with Sergey's the question?
On my part, it wasn't really a question. If you want, we can follow up on the
Okay.
list.
I agree. So I think for the second point, so that's related with the implementation. So we will have the more the work as for your information. Thanks for information. But for the first one, I say that that there's the cases that's maybe there's a huge number of the BGP session is set up. So that's once this is shut down. So that we will have the huge number of the BGP session we will have to set up again. So that will take much time. So that if we use the BGP QUIC for this the case, it can save much time. Okay.
Well, if you just measure the time on your overall BGP session establishment and route exchange, and when route installation into RIP, VIP, and so on and so forth, you will see this time is really negligible, and it doesn't make any difference whatsoever.
We can check, but in some cases, maybe the faster convergence is also important for BGP.
Okay, let's discuss
Okay.
offline because we're out of time. Thank you.
Okay, thanks. Okay.
Hello, can you hear me? Hello?
Linda, we can hear you. You're a little quiet.
Oh, okay. I'll speak louder. Okay. So next 10 minutes, I'm going to give some explanation on how do we use BTP flow spec to achieve this transport-aware mobility. So a little bit background on this. For the 5G services, 3GPP has done extensive work to optimize the application traffic, assign them to different slices, assign them to different underlay network. But primarily, most of the work are between the node B, which is the base station, and the UPF. And over there is GTP tunnel. GTP tunnel is a UDP-based tunnel. And there's a draft in the DMM working group on TN-aware mobility. So mainly to basically allocating different kind of traffic to different kind of to their appropriate underlay network using the UDP port range, because that's how 3GPP classify the application by different UDP range. So that was in DMM. And but the traffic not just stopping at the UPF, the traffic actually goes all the way to the their appropriate destinations. So a big chunk of the path actually is within the data network. So with that, there's a draft in the RTG working group on how do we extend this TN-aware to the data network. That was presented in RTG working group yesterday, describing multiple methods to push down the policies to the ingress node. So one of the policy is using the flow spec. Actually, Sue, can you go back one page? So the previous page. So for the, this one. So for the policy to the ingress node, there's other methods like PCE or other method, SRv6 policy. Specifically, there's a flow spec coming down. So this draft is just extending the flow spec aspect of the policy going down. For the flow spec, the background is there are a couple of drafts already in IDR. One is to redirect paths to different IP target. And the one we are very interested is using flow spec to do the path redirect, which direct to different IP tunnels. And also there's a flow spec for SRv6. But we find what is missing is really there could be tunnels which is IPsec associated. So we think we need a way to tell the ingress node a particular flow need to go through the IPsec tunnel, which is already pre-negotiated IPsec tunnel. So that is what this draft is about. Next page, please. Next slide. Okay, so in this slide, we just try to show that to assign traffic to a specific IPsec tunnel, there'll be two parts. One is the matching condition, one is the action. For the matching condition, we believe the current existing method for the flow spec is already good enough. For the action part, we think we need to add another action, which is redirect into the indirection ID for IPsec tunnel ID, IPsec tunnels. So that's what we think is missing for this. Next slide, please. So here, this slide just shows an example for the matching condition. The current flow spec NRI is already good enough. Specifically, the policy could be based on source address, could be based on the destination address, could also based on the UDP ports or TCP ports. So I think this is just an example showing what is there is already enough. The flow spec V1 is enough. Second page. Next page. What we need extra is because this policy is from the controller to the ingress node. Therefore, this is non-transitive flow spec, meaning that ingress node, when they receive the flow spec, they're not supposed to send it to other nodes. Therefore, we need a new code point from IANA for the non-transitive flow spec redirect to indirection ID extended community. So that's one thing we need IANA for. And second one is for the subtype. The subtype to indicate that the tunnel ID indicated is IPsec tunnel ID, so that the head-end node, knowing that they need to associate with what they have established prior to that, because IPsec tunnel requires much more than just IPsec, just the standalone IP tunnel. It requires key, rekey, and bunch of algorithm associated with that. So that's the new subtype we need. Another ID type, like in terms of tunnel ID, we should need different kind of inner encapsulation. For example, you could have inner encapsulation being GIE based or VXLAN based. So those are basic three IANA code points. One is the type, non-transitive flow spec, redirect to indirection ID, and subtype for IPsec, and IPsec ID types. So those are three things we need from IANA. And that's it. Next page. So this is the initial draft. We're looking for feedback, and anybody who, and also looking for people who are willing to work together, co-authors, or whoever interested in working together in this domain. Thank you.
Linda, Ketan reminded me to encourage draft authors of FlowSpec to indicate in the beginning of your introduction whether you're going to be either the V1 FlowSpec in as you've indicated, or V2 FlowSpec. So my understanding is this is intended for a V1 FlowSpec because it augments something that's already been targeted as V1 FlowSpec. Is that correct?
Yes, yes, correct. Thank you very much. Actually, I remember you have a summary of all the flow spec in the wiki page. Yes, this is just augment what is in V1.
So I'll add myself to the queue. So Linda, I think we're going to see two things that you're going to care about for this proposal. The first one is that the indirection ID you're talking about is a FlowSpec action. And for the most part, those are perfectly compatible with existing FlowSpec V1 behaviors. Authors are strongly encouraged to talk about how their forwarding action extend communities and other behaviors interact with other documented ones that we have out today. The main thing that is a point queued for FlowSpec V2 for actions is allowing for a lot stronger interaction and control when more than one is specified. The second thing I'd encourage you to think about is that your application for the match criteria in FlowSpec is at least written in the presentation as being very boring FlowSpec V1. That said, I think that, well, that's a good feature. One thing I'd urge you to consider is what happens if you have a device that's receiving these rules and happens to be getting additional rules on top of your application. Right now, the FlowSpec ordering is done in the RFC specifically by a sort order that's targeted for DDoS applications. I suspect that you're going to find that that sort order does not interact well with your application if it's allowed to operate in a mixed environment.
I get it. Okay, so we will definitely address that. Maybe add another section to the document to address the ordering issue. And how do we address that?
Thank you.
Thank you.
Yes, can you hear me?
Yes.
Okay. Is in one of your slides, it's showing a picture about the BGP flows back for the IPsec tunnel. I think the page 3 probably. You mentioned the endpoint is like a UPF plus PE, and then there I really got confused. Like UPF is within the 5G part, and the PE is not. So the first question is, from your BGP controller to which endpoint is going to send its control information? The second part, and how? How are going to through the 5G core network? How are you going to do it? So thank you.
Oh, okay. Yeah, that's a good point. On Wednesday presentation at the RTG working group, we have actually two diagrams for this. One is UPF integrated with PE. Another one is separate. So this flows back controller definitely is going to the PE. PE being a function, maybe within one box. One box probably perform both UPF and PE, or could be two separate boxes. This is definitely to the PE part. And in terms of the policy coming down, we assume that in a Wednesday discussion, there is a link between the 3GPP controller to the data network controller. There will be some kind of information exchange on the policies, the mapping of the policy, like what kind of traffic mapping to what kind of characteristics. So that is expected from the controller's perspective. We didn't draw here.
So basically, the UPF actually is out of the picture. Is that right?
Yeah, right. UPF is auto picture, which shown here is mainly to enforce that the traffic comes from UPF, and the characteristics could come from the 3GPP controller as well.
Yeah, maybe I can just add it here, Linda. Yes, if you see that other draft we have presented in the RTG, so that draft has much more details. There are combinations. UPF, the virtual UPF could be present part of the ingress P node, or it could be separated. It doesn't matter. At the end, when that kind of a traffic from the mobility traffic reaches to that ingress node, basically that policy is coming to the ingress node in the data network, not in that kind of a mobile network. And how we kind of redirect, that's what it talks about.
We're going to have to cut the line now. I apologize to Zhao Q. We're just going to need to go on to the next presentation. If you had a question, could you please send it to the email list? We're going to have a longer discussion on any flow spec drafts at an interim on September 13th, not 30th, September 13th. So please, would you send that comment to the list? I'm sure that it would help the authors.
Sure, I'll do that.
Thank you so much. We're
Thank
going to
you.
go on to the next slides. Just a minute. Okay, this is Time to Live. It's another BGP flow spec. Philippe, are you ready?
Yeah, can you hear me?
Okay. Yes.
Excellent. Thank you. Thank you, Drew. Yes, so this presentation is about the TTL, time to live, as a new match criteria in flow spec. So if you can move to the next slide. All right, so the main motivation is for DDoS mitigation using TTL values. So the main target are flow spec V1 compatible routers. And the draft is fairly simple. So it defines a new component for the TTL value, reusing existing encoding for similar IP header fields. And so if you look at recent studies, such as the one that was presented at NANOG 82 called Tracing DDoS End-to-End in 2021. So that study was highlighting how filtering traffic based on TTL values can be used as a very effective mitigation against volumetric DDoS attack. So moving on to the next slide. So here I have extracted two snapshots from that presentation. I would highly recommend, if you're interested, to go through that presentation at NANOG. But basically, the authors are going through various steps. One of the first steps is to look at the various DDoS for hire services, sending direct attack or amplification attacks, and trying to identify the source of the traffic. And that's one part of their study. And the second part of their study was to look at the network under attack, so the victim. And when looking at the network under attack, they were looking at the TTL distribution for the attack traffic versus the regular good traffic in the network. And that's what you can see on the right side of the slide. So what you can see here is that the good traffic is the blue on blue. Yeah, you see in blue, and it's highlighted by different operating systems or cloud operators. And basically what it means is that the known good traffic is coming from very few hops away. And that's something that's a characteristics of the networks nowadays, where most of the traffic is sourced from very few ES and cloud providers and not coming from very far away, right? Whereas the DDoS on the other hand, from those 50 plus DDoS for higher services, that distribution was basically the entire TTL space. And so by using this and having the TTL as a filter match criteria at the edge of the network receiving the DDoS, it becomes particularly easy / it's an additional tool that the operator can use to mitigate the DDoS by either allowing the range of known good TTL values for normal baseline traffic, or using the ranges of the bad TTL values. So if you're moving on to the next slide. So I really have just one last comment. There was a comment on the early version of FlowSpec 5575 bis about TTL. So the comment was only in the early version, it wasn't in the draft, but it was something along the line of the TTL not necessarily being potentially a meaningful match criteria because it changes every hop, right? Indeed, the TTL values is decreased at every hop. However, when you're looking at those DDoS mitigation studies, and especially this last one, actually the TTL values can be used as an effective mitigation. So different IP router at the edge of your network, so typically the peering edge of the operator network under attack, right? They can use that TTL values as ranges for mitigating the attack, for the attack traffic going to a particular target or multiple subnets within their own network that are under attack. So in summary, the TTL value is available in multiple router vendors today. It is just not present in FlowSpec, and we have one very useful additional tool for the operator in terms of DDoS mitigation. And I'm going to open the mic for questions, comment.
Ask one question. First, again, you're proposing this for V1 FlowSpec, but it might be something you also would like to see in version 2 FlowSpec. Did I understand that as well?
I think you're right, Sue. Yeah, the primary target is for the existing router in V1, but I don't see why it would be excluded from V2. Indeed. And actually, to interject, and unfortunately, based on the consensus from the working group, even though this is a DDoS type application, this doesn't fit into the V1 encoding without some ability to carry safe capabilities across here. You know, with session notifications if this additional component's present on implementations that received it and didn't understand it. So the current consensus is this probably needs to go to V2. So Jeff, your comment is about any new component in general? Correct. So I'll go ahead and paste to the chat a pointer to the draft that I had started for the flow spec capability bits, which was a proposal to try to carry new things in V1. It describes the propagation problems that the current flow spec protocol has for carrying new reachability for new component types.
Yeah, so I've seen this draft, but does it mean that, are we saying that adding any new component without that draft is impossible?
Effectively, yes. Sorry, let me clarify. The draft was an attempt to actually describe how we could do this in flow spec V1. The consensus from the last interim was we would not take that forward and that we would have to do this via V2.
Okay, understood.
And I'll add to Jeff. Our hope, because of that feedback, was to move V2 quickly forward. Hence, I've created a prototype draft, and we hope to move quickly. So we'd appreciate your help in putting this type of useful feature into V2.
Okay.
I mean, Philip, hey, this is an exciting presentation from Nanog and a feature that was one of the reasons Jeff had features like these are one of the reasons Jeff suggested the capability bits.
Yeah, I was particularly excited by that. I didn't realize that it was rejected, that capability bit.
Was the
Good to know.
feedback got from the list. We're always and from the interim, so we're going to go ahead and try to push quickly toward V2. Anyone else for Philippe? Fascinating presentation. And a feature I'd love to see. Okay, folks, I'm going to go ahead to the next presentation. Jeffrey, it's your turn. Please go ahead.
Thank you. This is a simple draft about label stack sub-TLV in the tunnel encapsulation attribute. Next slide, please. So in the newly published RFC 9012, there is this MPLS label stack sub-TLV. Its semantics is that that label stack is specified in that sub-TLV will be pushed before any other labels. When I read that recently, I was wondering why before. If we want to push steer the traffic to the tunnel endpoints, should we push that label stack after pushing the other labels, for example, the service label? The spec does not talk about it, and after some asking around, I finally got the answer that that sub-TLV is not for steering traffic to the tunnel endpoint. Rather, it is to steer traffic after the tunnel endpoint. Next slide, please. So that's is a picture here. We have at the core domain, and we have side 1 and side 2. There's a border router BR1 and another one BR2 between those sites and domains. So when the BR1 gets a BGP update with the tunnel encapsulation attributes, the attribute could carry a MPLS label stack sub-TLV, and the BR1 would push that label stack first and push other labels such that when BR2 gets that packet, it will be able to use that remaining label stack to steer traffic inside site 2. So that is the intended use case for that sub-TLV. The spec was not clear about it, so we thought that it's good to clarify that the intended use case. But then another question is, what if you do want to steer the traffic from the BR1 to BR2, which is the tunnel endpoint? Right now, the spec does not have a way to do that. Next slide, please. So to achieve that, we define a new sub-TLV. Now we call it tunnel label stack. It's basically to specify a label stack that is used to steer traffic to the tunnel endpoint. For comparison, the existing one is for steering after the label, after the tunnel endpoint. Oh, I have that typo in there. It's for steering traffic after the tunnel endpoint. So this new sub-TLV has exactly the same encoding as the previous one, except that the type. Next slide, please. So in summary, there's a simple small draft to clarify the existing use case for the existing sub-TLV, and we define a new tunnel label stack to steer traffic to the tunnel endpoint. It's a simple. I believe it's ready, but of course we want to seek comments, and if people agree, I think it's good to have it adopted. Comments?
A bit tight, so I'm going to go right on to the next presentation. I believe, Jeffrey, that's yours. Is that correct?
Yes.
See if I can. Jeffrey, I am missing. I have MPLS tables, but I do not have a community in there. Just a minute. Can you hold tight and we'll pick that up? I'm gonna work on it while we swap over to the beer. Is that okay, Jeffrey? We'll come right back to it.
Sure, no problem.
Thank you. Okay.
Hi, this is Huaymo. Can you hear me?
I can hear you real clearly. Thank you, Waymo.
Good. Hello, everyone. Today, I'm going to talk about the BGP for BAT pass. Next page. First, we have an overview about the BGP for BAT pass. And then we have, first we have an instruction to BATE. For BATE, so in a BATE network, every egress node has a bit position. For example, node D has bit position 1, node A has bit position 5. For every link in the network, on each side of the link, there is also has a bit position. Here, for example, for link between H and D, so on H side, we have bit position 28 A prime. On the D side, we have 27 B prime. So every node in the network has a forwarding entries for its adjacency bit positions. For ingress node, the ingress node will have a BAT path. That BAT path is encoded in bit positions. With this BAT path, after receiving multicast package, that ingress node will encapsulate the package with those paths encoded in bit positions. So the idea of BGP for BAT path is that the controller will have connections to some nodes in the network. The controller will compute a BAT path and distribute this path to the ingress of the network. And then the ingress node can use this path for after receiving any multicast package to be transported by that path. The ingress node will encaps the package with that path, and then the package will be multicast along that path. Next page. So let's look at an example. So here we have a path from A to node D and H. So this path is represented in green color. So this path is encoded by those bit positions. For example, the branch from A to H is encoded by bit position 26 prime, 20 prime, and then 4. So the controller will compute the path. After the controller has that path, it will distribute this path to the ingress nodes of that path. So ingress node can use this path to distribute multicast package along the path. Next page. So the distribution path to ingress node just follow the normal BGP procedures. So we have two different cases here. One is ingress directly connect to the controller. Another case is not directly connect to the controller. So basically, BGP will have a update message. This message will contain the path, and we will have also RT, and then controller will just advertise this package to all its adjacent node, and then until that package reach to the ingress node. So next page. So we propose two options for extension to BGP. So one option is that we define a new tunnel type for BATE on the PMSI tunnel attributes. Another option is that we define new tunnel type for BATE on the tunnel encapsulation attribute. So for the first option, so we just those attributes will contain the information about BATE path. So for example, the information includes path ID and then the real path, which is encoded by those bit positions. So this path, those real paths, we can represent it by a sub-TLV. And then we can also contain another information such as path lane. So next page. So this just give a sub-TLV which encodes the path bit positions. Basically, this TLV contains the bit positions for a BATE path. So next page. So another option is that we can we define a new tunnel type for BATE on the tunnel encapsulation attribute. So in this attribute will contain the information about a BATE path. So this information is encoded in sub-TLVs, such as the path bit position sub-TLV, as I mentioned in the previous page, and the path name TLV. In addition to this one, we can also have path ID sub-TLVs and the traffic description sub-TLVs. So next page. So I would like comments from the group.
Apologize. We're gonna just a minute. Take that to the list. One thing I'd like you to look at is the interaction between PMSI tunnel attribute and your work. I'll send a message to the list on that. With that, we're going to pick up Jeffrey's presentation. And again, I apologize for the delay.
Okay, thank you. Thanks, Joseph. Thanks for your comments. Good.
This particular one on the meeting materials. It may take me a moment, and again, I apologize. Unless Jeff Haas, if you have it up quicker, I'm gonna see if I can find it. Okay, folks, I'm gonna have to display this from my own slides. It may be a little problematic. There it is. Maybe I've gotten it now.
Yeah, I couldn't find it.
I couldn't find it either. Okay, let me pull it from my own.
I can actually start talking now.
Go ahead and start talking, and we'll see if I can get this
Okay.
up quickly.
So-
Go ahead.
Okay. So I'm going to talk about deriving extended community from a route target. So actually the slide is coming, so I'll just wait for it.
Can you see the slide at this point?
Yeah. Yes, it's displayed. Yeah. We can go to the next
It's
slide.
a little funny, but if you would tell me when to work through slides, shall I go to the
Yeah.
second slide?
Yep.
Okay, go ahead.
Yep. So a general example use case is like this. Let's say you have a VPN with 10 PEs. That VPN has a route target RT1. The route target is extended community with a subtype 0x2. In this case, if we call the extended community EC1 and we call the route target RT1, they are actually the same. RT1 equals CC1. But when we say route target, we emphasize that it is a special, well, it is an extended community used to control the propagation and importation of the route. Now, when we don't say route target, we just say extended community, that particular semantics is not implied. Now, consider that you have a PE10 that needs to propagate a route to PE1 only. And then PE1 needs to know that that particular route that is targeted at itself is related to the VPN. To do that, we use another route target, RT2, attached to the route so that only PE1 will import it. Now, to associate that route with VPN1, with the VPN, we need to attach another extended community. That community will allow PE1 to know that that community EC2 is related to the VPN. Now, in this case, the RT2 and EC2 and RT1, they are not the same. They are totally different. Now, while RT1 is for the VPN, associated with the VPN, we cannot attach RT1 to that route because if we do so, then that route will be imported by all other PEs, which we do not want to. So now we use that EC2. It can be any arbitrary extended community configured to be related to that VPN. However, it would be nice if we could derive the EC2 from the RT1. So we know that RT1 is related to this VPN. So if we could derive another community from the RT1, that would be great. Next slide, please. So to do that, we say that for any route target, we can derive an extended community from it simply by changing the subtype to a new value. And with that, from that derived extended community, you can also recover the original route target. So we have already applied and got assigned a subtype 0x15 for this purpose, for the those registries, like 2-octet AS extended community and so on and so forth. Next slide, please. So we talk about general use case. There are two specific use cases that I'm going to skip here. I do want to clarify that the second specific use case is just a theoretical use case. Or I shouldn't say, let me rephrase. It's not the intention of this draft to change the behavior. I'm just point out to show that this could be used to do whatever is or what is already defined in that existing draft, but we're not changing that behavior. Just use this to show a specific use case, but I will skip it. Next slide, please. So this is a simple informational draft. The whole idea is the purpose is to share this idea for deriving an extended community from a raw target. I'm sure there will be other use cases that people can use this for. Well, I'm seeking comments, and if this makes sense, I'd like to have the working group adopting it, even though it's an informational draft. That's it.
We're all at 6:31. We had a request from Ventat on that. Would you, if you'd like to stay around, we can go through Ventat's presentation. Just a minute while I swap back and I will let him. Otherwise, Ventat, we can, I didn't see him earlier. Is Ventat here?
Minto will be presenting.
Yes, you are. Okay.
We can hear you.
Let's see if I can get the presentation up quickly. Okay, hold on. I'm sharing it. Go ahead. You have about 5 minutes before I think we quit, and with the kind indulgence, we'll just go ahead and pick that one up. Go ahead, Ventant.
Hey,
Well, also,
Susan. Sorry,
go ahead.
I'm into. Are you able to hear me?
Yes, I am. Please go ahead.
Okay. Hey, I'm into. I'm presenting the BGP peer auto discovery proposal on behalf of Shiva and myself. Can you please go to the next slide? Thank you. The scope of the work is to reduce per node per peer BGP specific configuration, and this will be scoped for the single GOP layer, single GOP BGP session. This also includes the BGP session formed using the loopback addresses for the directly connected BGP neighbors. So in this protocol, we plan to use that to send the BGP transport parameter so that BGP could form the session using that advertised parameters. Yeah, please next slide, please. This is a simple UDP based multicast protocol to mainly support the V4 and V6, and also remove the dependency of the layer 1, layer 2 media encapsulations. So the contents in this protocol advertised using the TLV based. There's all these TLVs are grouped with the messages, and the content of that the transport information and the base protocol information is advertised with the expiry lifetime, and that information is periodically refreshed before it expire. This protocol also provide a flexibility to the sender, which can advertise if it notice any new neighbor, new sender, or any local configuration, so that it will increase the or it will quickly do the faster discovery. This entire information or this protocol is kind of loosely coupled with the BGP, loosely coupled with the BGP. Yeah, thanks. Next slide, please. The PDU layer has as usual the PDU header and set of messages, and each messages have a set of TLVs. Right? The PDU header is like any other protocol, have that version and length along with the identifier to identify that the sending router. Also, this version will define two messages. One is that base message that is mainly for the base protocol operation, and that and the BGP message that for the BGP to authorize its transport parameters. Yeah, please, next slide, please. So the base message is mainly for the the protocol base operation. Protocol operation. It has this draft define a couple of TLVs, and one of the important TLVs is the remaining lifetime. The remaining lifetime will give you the entire content life, and the lifetime is sender driven. It means that in any given link, the sender could sender could dictate what that when the content will expire. Right. The other couple of TLVs on the one is authentication and the config sequence. The config sequence will provide you with any interesting local config changes that will hint the remote end to do any more actions. Yeah, please. Next slide, please. This is mainly for the BGP transport parameter. This message will describe what are the transfer parameters if wish to advise it. Right. So there are a couple of security TLVs, the TTL and authentication, other than the authentication, and the local address TLV that will be tell what is my local transport address that wish to form a session. And that transport preference, if you have the couple of, if you have both V4 and V6 transport, it's what is its preference to form the session in the case where only one session is formed, one transport session is formed. Right. The link address will be useful in the case it will provide a reachability to the local address in case of the data protocol is used for either V4 or V4 in the case of the preference is V6, and the V4 in the case of preference is V6. And the TCP MSS is it's on the TCP parameter. That's all the TLVs in the first version defined. Yeah, next slide, please. That's all. So we will probably going to push that next version another week or so, and we will send it for the IDR for more comments and.
There will be an interim in October on auto configuration, so I hope you will have another version in discussion. AC, you may ask your question while we're till they cut us off.
AC Lin of Cisco Systems. It's just a comment. This is really similar to Xiaohu's draft, which really emulated the LDP discovery. Only the difference in this one, it's different in code, a little bit different in coding, and it has the benefit of copying the stuff from the other proposals in the design team. So it had the benefit of the requirements document. Other than that, it's basically the same.
This is very simple protocol. It doesn't have any two-way it doesn't have any neighborship or anything, but the implementation can make use of that to build the neighborship, and the content will be kind of expire based on that sender.
Yeah, just to interject, the lack of the state machine was probably the biggest change versus the LDP-ish one that Xiaohu did. Xiaohu's was out of all the proposals that were previously published, probably the best spelled out one. It benefited a lot from a lot of LDP thinking, but part of the design team considerations that we had over our analysis was that session-based was probably not what we wanted to do. We were going to more announcement-based like we did for the L2 solutions.
Yeah. Okay.
It's kind of a service advertisement than the that's a neighborship.
Yeah. We certainly need more auto discovery proposals.
Hopefully we'll start thinning them out. So a thing I recommend everybody interested in this work across the board, we're to the point of we've agreed in the design team what the requirements are, what the contents are. we're down to the boring details about making the PDUs look like something that our implementations are happy about. So if we have specific encodings that we like from each of the different proposals, throw those out on the list. This is a good time for us to actually figure out what small details we want to take care of in the next proposal, whichever one we decide to adopt across IDR.
The session with today was the deadline to send the chair's comments about the requirements. We'll consider them complete. And with that, we'll thank you for your extra 10 minutes and hope you have enough break before the exciting LSR session next. Have a great evening or day.